In this video, we'll look at finding the trigonometric function values for some angles that occur in certain special triangles that have pleasing geometry. In general, it's difficult to find the exact value of the trigonometric functions for, say, sine or cosine of tangent of any given angle that you pick. And at best, we tend to use a calculator to give us an approximate value. But in this video, we'll talk about some nice angles that have nice exact values that we can discern. The first example is a 45-degree angle, and to achieve a 45-degree angle, one way of doing that, you might start with a perfect square, and I'm going to label the sides of that square to be all of length 1 unit. The corners are 90 degrees all the way around, and 1 unit in length all the way around the sides. I'm then, in order to get a right triangle, going to divide it down the diagonal, and when I do that, I'm going to take this length right here, and that's going to form a 45-degree angle. Recall that 180 degrees is pi radians. So if I divide that into fourths, I get 45 degrees, so that must be pi over 4 radians. So this angle here is 45 degrees, as is this angle over here, and let's just write it in radians as well. It's pi over 4 radians. I am missing the hypotenuse of the triangle, the diagonal, so I'm going to find that hypotenuse. It's square. It should be the sum of the squares of the legs of the triangle, so 1 squared plus 1 squared, so it should be 2. And if I then find the positive square root of that, it will be square root of 2. So the diagonal length here is square root of 2 units. We can now find the sine of 45 degrees, the cosine, the tangent of 45 degrees. All of these are equivalent of asking for the sine of pi over 4 or cosine or tangent of pi over 4 when interpreted in radians. So it's essential that you have the units here to convey that choice. No units over here, radians, degrees over here, so therefore degrees. And we can read off these values by looking at the angle however we want. I'm going to sit here at the pi over 4. Sine is opposite over hypotenuse, so it's going to be 1 over square root of 2. Same for the cosine. The cosine is adjacent over hypotenuse, so I'm standing here at the pi over 4. Adjacent over hypotenuse, 1 over square root of 2. And then finally, the tangent is the opposite over adjacent, so it's going to be 1 over 1, and of course that will simplify. In fact, all of these are typically written in a simplified form. People typically will rationalize the denominators here. Whenever we see a radical in the denominator, people play this little game of multiplying the top and bottom by square root of 2. That doesn't change the number, and it moves the radical into the top. That's just a simplification, just a choice, a convention that's done. Similarly, for cosine of 45, it is root 2 over 2. And then finally, tangent of 45 degrees is in fact 1. There is another nice triangle that gives us a couple more trigonometric function values. What I'm going to do is start with an equilateral triangle. That means all the side lengths and all the angles are the same angle. That is not a right triangle, so I can't do trigonometry right now. I'm going to make it a right triangle by splitting it into 2, and because of that I'm going to choose, because I'm in charge here, I get to set the scale however I like, I'm going to make all the side lengths to be length 2. Then the angles will be 60 degrees because they're all equal angles and they all have to add up to 180, so a third of 180 is 60 degrees. In radians, that's pi over 3. I take a third of pi, which means all these other angles here, if I want to write it in radians now, is in fact pi over 3. Again, not a right triangle, so I'm going to split it right down the middle. When I do that, I get a right angle on either side here, and the lengths of these little sides now become 1, which was the reason I chose to make the side lengths 2. We just need to determine this side right here, and this angle right here in the right triangle. In fact, that angle is 30 degrees. 30, 60, and 90 add up to 100, or 180. And in radians, a half of a third will be a 6, so pi over 6 radians in that angle. Okay, so we just need to find this height of this triangle right here. Its square plus the square here should be the square of the hypotenuse of the triangle. So height squared plus 1 squared should give me 2 squared. that means the square of the height should be 4 minus 1, it should be 3, and taking the square root should give me square root of 3. So that height is in fact the square root of 3. I can now read off the sines, cosines, or tangents of pi over 3 or pi over 6 using this 30, 60, 90 triangle label as I see here. So let's do pi over 3 just for discussion. That's the sine of 60 degrees as well, or cosine or tangent, and here they are all written out. Don't be put off by the different ways of writing it. 60 degrees, pi over 3 radians. And I look at pi over 3, I look at that angle, I'm imagining myself standing at that point, and I say opposite, square root of 3, hypotenuse, 2. So I'm going to get the ratio square root of 3 over 2. I then think about the cosine, that is adjacent over hypotenuse, so 1 over 2. And then finally the tangent is opposite over adjacent. It's going to be square root of 3 over 1, which is in fact square root of 3. And I'll let you practice here. You might pause here and just do the sines, cosines, and tangents for the angle 30 degrees or pi over 6 radians now.